Okay, so let's take a look at a few more examples here. So, for example, A, we have that the limit as x approaches A. So we're talking about here. And we can see that as we approach A from the left on this function, which is called f, that it's supposed to go to infinity. So we write that like this. Okay, and here as we approach from A to from the right, which is A plus, it also is going to infinity. And here, as we approach A from the left, it's going to minus infinity. And here, as we approach A from the right, it's going to minus infinity. Okay, so these red lines here have a name, and they are called asymptotes. So the point of the asymptote is that the values get closer and closer to that line, but actually never touch it. Okay, now we're also going to talk about, suppose we had something like this. We'll talk about this also as being an asymptote. So in this case, we'll call these vertical asymptotes. In this case, we'll call them horizontal asymptotes. Asymptote. So when we have a vertical asymptote, so we say, so for example, here we have a vertical asymptote at x equals a, or here, same thing, at x equals a. This one we're going to talk about this as being, say, a, and then we'll say there's a horizontal asymptote at y equals a. So when we have a vertical asymptote, we can it's going to be at x equals something. So x equals a, or x equals whatever this happens to be. So we're going to have a vertical asymptote where x equals a. And that means, what does that mean? That means the limit as x approaches a could be from the right, could be from the left, or it could be both, but the limit as x approaches a, either from the right, left, or both, is going to be either infinity, as it is here and here, or minus infinity, as it is here and here. So when we have that, I guess I'll write plus or minus infinity, I don't know. Could be either one, in other words, that's what I'm trying to say there. Then this could be plus or minus, or just the general limit. Then we say we have an, so if we have this kind of behavior, we have a vertical asymptote at x equals a. This, and so what? Is there a vertical asymptote here? Yeah, at x equals 0. Why? Because if we look at the limit as x approaches 0 from the right, for example, we could do from the left, or we could do both, actually, in this case, but we only need one of them, of 1 over x squared, we get infinity, positive infinity in this case. Okay, so then we can say that there's a vertical x equals 0, which is here. Vertical asymptote at x equals 0. Let's consider another function. Let's look at this, and let's think about what would be the limit as x approaches 3 of 2x over x minus 3. Now, we don't have a kind of methodical way of doing this yet, but we can just think about it. Hopefully, we'll come up with a kind of more methodical way to do these, but right now we'll just kind of think about it. This function looks like at 3 or near 3 as x approaches 3. So we're just going to think about it. So the top part, as x gets close to 3, the top part we can say sort of approaches what? Approaches 6, right? It approaches 6. As x gets close to 3, this is getting closer and closer to 6. And the bottom part, as x gets closer and closer to 3, is getting close to 0. So we're kind of getting 6 over 0. Okay, so let's narrow this down a little bit. Let's say this instead. So now, what can we say? Again, as x gets close to 3, but even from higher than 3 or from above 3, this is still getting close to 6. And when this gets close to 3, but from above, then we're going to get like, let's think about it. Suppose x is first equal to 5, and then 3. So what happens to x minus 3? So when x is 5, we get 2. When x is 4, we get 1. When x is, we get 0.5. But the point I want to make here is that these are all positive, because when x is approaching 3 from the right, it means bigger than 3. So this bottom part is going to be positive. So it's going to be getting closer to 0, but it's always going to be positive. So what does that mean? That means that we kind of expect that the whole thing is going to infinity, because you're getting 6 over something very small, means it's getting bigger and bigger. So it leads us to believe, well, so this is equal to positive infinity, maybe. According to our analysis, this should be maybe equal to positive infinity. So what does that mean? That means we have a vertical asymptote, because that's what we said up above, that when we have these things, we have a vertical asymptote, and we have one of those conditions here. So it means that we have asymptote at 3. Now let's just take let's see what happens if we do the limit from the left-hand side. So let's do this. The limit x 3, but from the left-hand side of the same thing, 2x over x minus 3. So what's the difference between this one and this one? Is that before we said this was going to be positive, always positive. It's going to go to 0, but it's going to be always positive. But if we're coming from the left of 3, that means numbers smaller than 3, then x minus that is going to be negative. So we can see that the top part is going to be 6, the bottom part is going to 0, but it's always negative. So the ratio is going to be negative, so it's going to be negative infinity. So that also means that we have a vertical asymptote at 3. So we have 2 reasons to say that we have a vertical asymptote at 3. And we also sort of know what this is going to look like, so that as x goes to gets close to 3 from the right, it's going to positive infinity. Maybe that was too dramatic. And on the other hand, as it gets close to 3 from the left, it looks like that. We have the vertical asymptote, and the picture looks something like this. I'm not sure what happens in this direction or in this direction. We didn't think about that. But at least here we know that it looks something like this. Okay, now let's take a look at this function. So this is y equals the ln of x, or the natural log of x. And we know, we talked about this before, we know that it's the inverse of y equals e to the x. We know that y equals e to the x goes through the point here. We know that it looks like this. And this is the inverse, something like this. So if this is the picture, then what can we conclude here? That there's a vertical asymptote here at x equals 0. So we could draw a red line here and say there's a vertical asymptote there. Okay, that means, what does that mean? It means, hopefully this is true, that the limit as x goes to 0 from the right of ln of x is equal to what? Minus infinity. Okay, so if you recall this graph, then you must agree that that's what's happening here. So now what about this? As x goes to 0 from the left, what about that limit? Suppose I did try to think about that limit. Well, we can't, this function is not defined when x is to the left of 0. So we can't even think about that. The function, the domain, is only to the right of 0. Okay? We can't even think about this. But this we can. So as x goes to 0 from the right, then it's going to minus infinity. So we have a vertical asymptote at x equals 0, and the picture looks like that. Okay, as a reminder, you cannot consider x's to the left of 0, ln of x. Remember that this relationship or this function is equivalent to this. It's, first of all, we could rewrite this as the log base e of x. So remember that that is equivalent to e to the what equals x, right? So can we ever get a negative x here? And the answer is no. You can never get it, no matter what y you put in for the exponent of e or any number, any positive number, you'll never get a negative x. It's one reason to understand why this is never, there is no negative values for x for the input. If that's using, let's, instead of using e, let's use just 10. So can you raise 10 to any power and get a negative number? No, you can't. Of course, if you put 10 to 2 or 10 to the 5 or 10 to the 20, that's going to be negative. And you might say, well, what about 10 to the 1/2? That's the square root of 10. But when we're doing this, we mean the positive square root of 10. So there's no number up here that we can raise 10 to get a negative result. So there's no, so x will never be negative.